Hello friends, Shivansh this side, and today we are going to solve this organic problem. Here is an image as well, sorry, and there's something at A as well. So let's start the video. Here we have ortho nitrotoluene plus C double bond C, C double bond O, pH. This can be called as, this is phenone group, vinyl phenone types. Okay, and this is an image, it will give you something. So NaOH is a base. First thing of base is to extract a proton. But from where it will extract? Let's see, where do we have hydrogens? Here hydrogens, here hydrogens, here three hydrogens. Benzene also have hydrogens, but they're of no use, of course. NaOH is not stupid enough to take hydrogen of benzene. So it will not give hydrogen, not take hydrogen of these, because there is no stabilizing factor of them. Because anytime carbanion is formed, there must be resonance stabilization. But if you argue that we may remove these one, so first of all let's make orbital diagram or hybridization structure of that. Like C double bond C, it is in molecular plane. Now perpendicular plane we have this thing, again molecular plane, and perpendicular plane, again molecular plane. Perpendicular plane we have this thing, perpendicular plane we have this thing, and it also has two lone pair in the plane. Okay, so if I abstract a proton from here, then the p orbital will be formed in the plane, and it cannot participate in any resonance with these pi bond because they're out of the phase. In every bonding, the overlap must be along the plane, like positive overlap must be there. These two orbitals can overlap, these two can never overlap. And then you might argue that why not remove this one? Again, this will not overlap, this will not overlap. Here we don't have any proton, so next option is this proton. And yes, this proton will be removed because its conjugate base is this thing, NO2, sorry, NO2. There are something like we have to do many more things on A, but let's first of all make A and CS3. Now when we remove, we get a conjugate base like this. Now if we see nitromethane, it is a very strong acid due to minus M effect of this, and same minus M effect is over here. You may say that minus I is nice over here and here it is less, but minus M is almost same. One more thing which will explain its stability is ortho effect. That plus M, like, but I don't believe in ortho effect in this case because then all stabilization will be gone. Okay, so if you're supporting me, then no ortho effect. But anyways, some, because also these two groups are not too large at COOH group for ortho effect. But anyways, orbit, like plane flipping, it will get devoid of plus M of benzene. However, let's forget it. Anyways, so step 1 is extraction of proton, and here we get this. Now step 2 is, it's a nucleophile now. Step 2 is nucleophilic addition. Okay, because no substitution can take place, because if it, like, what is leaving group, only this is a possibility, and phenylion is not a good leaving group because it's a good base, very good base. So let's find out electrophilic site. If we make a resonating structure of it, it will be something like this. Right, so in this structure, how many resonating sites we have? First of all this one, then this one, electrophilic sites, And one may argue that electrophilic substitution, sorry, the what did I said? Sorry, electrophilic sites. These two are there. Okay, now let's see it. Let's okay. My claim is that attack would be here. Now let's gather some facts to prove that claim. Number one fact is that when we will make a resonance hybrid, its electrophilicity is reduced due to plus m of it, and its electrophilicity is increased due to minus m of it. Okay, number one is plus m of this and minus m of this. Okay, second effect is steric. Here pH is there. I don't think it will attack. Let it attack over here. Okay. Also, we may say that C double bond C is stronger than C double bond O. But here this C double bond D is situated all around the things. Like C double bond C is here as well. C double bond O is also opening, but still. Okay. So attack will be here only. So on it, here is the attack. Now with the attack, this bond will shift here and this bond will open up. Hence we get this. And from flying H plus it will catch H plus and we will get this, and we will get one more ketone again. I hope what I have done is correct. I think it is. Now here is NO2 group and this is our A. Now next thing which is given in the question is like not like it's a part of a question, but next thing what we have to do is first of all SnHCl, which will reduce to NH2, and then we have NaNO2 HCl plus H3PO2. So first of all we have SnHCl. Sn plus HCl reacts to give SnCl2 plus this nascent H attacks on it and it gets reduced to NH2. NH3 plus precisely, but let's NH2. Now let's for simplification just see it like this. This NH2, NaNO2 plus HCl gives HNO2. HNO2 is not very stable and it gives NO as a nucleophile. HNO2 gives NO as a nucleophile plus NO. So it attacks on NO and it gives PHNHN. Oh, sorry. NO plus, of course. This is a nucleophile. Okay, now it's a lone pair. It comes down and this thing gets positively charged, so this flies over there. No, sorry, this goes down, this goes there, this flies over there. This is PH and H double bond and O minus, This happens again, we get pH and triple bond N plus Cl minus due to HCl. So next thing is, this is known as benzene diazonium chloride. Next thing is adding H3PO2 to it. Now H3PO2, if we draw its structure, it looks like this. These are H which are oxidizable. That means it's a good reducing agent. Now let's see what's the oxidation state and all of thing. It is reducing agent, which means it can give electrons, right? And here what is happening? This is a very strong plus I, like plus I group effect thing. Minus I. It's trying to take all electrons so that it can fly as N2 to gain entropy from the system. So it will take electron from pH. Phene takes electron. This goes like this, and like H goes at HCl, and we get pH. That is benzene. So like not benzene in this case. Here NO2 will simply get vanished. Okay. So next thing in question was addition of NiH2. Okay, let me jot it down first. Just a minute. So this is the compound we get after reacting Na2HCl, SnHCl, S3POT, S3PO2. Now what we are doing is adding NiH2 over here. NiH2 reduces all double bond by adsorbing it on its surface. So it will get reduced to OH. And now next step is adding H2SO4 in H plus in it, which will make a carbocation over here and electrophilic substitution over here, and we will get this. So this is it for today's video. I hope you like it, and please like the video and subscribe.